Hello, my name is Mike Allen. I'm the Global Vice President for Innovation at BeyondGravity. I'm located in Denver, Colorado, USA. And welcome Space Summit attendees. First, I would like to acknowledge the organizers. I appreciate the opportunity to speak at the summit. Today, here is the figures for BeyondGravity. We have 1,600 employees across 12 sites. In 2021, we had 400 million in sales. And I'd like to point out in the bar here, we have over 40 years of experience in designing and building space technologies. We have 1,100 hardware systems on orbit with 100% operational success. One area I'd like to expound upon is BeyondGravity has not just done Earth missions, but we've gone out into deep space to the lunar area and also Mars and beyond. And here's some of the programs that we've done in the past 40 years. I'd like to point out some of the major programs in the European area. First is Galileo, doing location, just like GPS program. We did the signal generator for this platform. MedOps is a weather platform to look at radio occultation and look at temperature and humidity. Next, we did the body of the rover in a composite structure. And then on Copernicus, we did Earth observation mission for this platform. Next, I'd like to focus on the US. This is James Webb Space Telescope. We had several subsystems on the telescope, and also we provided subsystems on the launch vehicle to launch it into orbit. We participated in ICESat with NASA, measuring the ice sheet mass balance. And then presently we are working on Space Launch System with NASA out of Marshall Flight Center. Here's some of the subsystems that we did. On the launch vehicle, did the fairing, onboard computer for guidance, and an adapter system. On James Webb itself, we did mostly the mechanisms cover. We actually developed the antenna system for James Webb. A new inventor, we have Plato program, and Plato is to find and study extrasolar planetary systems. We did the remote terminal unit and also the onboard computer. And on the JUICE mission, this will explore Jupiter and the 3 of its icy moons. Again, we did the antenna system here and then the management system. I'd like to take a little time to talk about our electronic systems for you and see if this would help you in configuring your missions for human space. First is the satellite and launch computers. Talk a little bit more about that. Navigation receivers and signal processing. Talk a little bit more about that. Won't touch on power and drive electronics, but we have a whole host of units for anywhere from solar arrays to platform drives and also power distribution units. Another one is for telecom, the big birds in GEO for microwave, doing up-down converters and LNAs. And the last is antennas, and I'll talk a little bit about that. So on the satellite and launcher computers, we've done command and data handling, over 150 satellites with this type of system, the guidance and controls for launchers. Up on the upper right, payload electronics. We do all types of payload electronics, from instruments to run the instruments or to control different systems on the satellite itself. And the last one is new space products, which is really looking on to doing onboard computers and single board computers. We do have one product that's called Lynx. That's a high processor for satellites, which you can put in algorithms and use AI and ML to do your mission. One of the challenges is to develop autonomy systems, especially if you're going into deep space. Some of the challenges is the radiation, making sure the radiation hardened and fault tolerance on the components. Operating temperatures, you have a variety of operating temperatures, and then the communications delay. If you look at the bottom of the chart, you can see the different communication delays that we have. From Earth to the moon, it's about 1.3 seconds. But as we go out past the moon, and let's look at Mars, then you're looking at anywhere from 3 to 21 minutes that you have to design for. So we do systems like this, and would like to help if you have any needs for this. Next is navigation systems. Is how do you determine your position if you're in cislunar or even in LEO? So we have developed a receiver in the past for LEO. It's called Podrix, and this is for precise orbit determination. We use any of the location satellites like GPS, Galileo in this receiver. There was so much need that we developed a receiver for GEO, and that is definitely used for orbital raising and just keep the determination of the location of the satellite. We are investing internal money to do new space type of navigation receivers. We're looking at LEO and MEO at this time. Those are being developed. When you do purchase a system for navigation from BeyondGravity, we also work with you to understand what your mission is, what other systems you have on the satellite platform, and we design the antenna to actually not interfere with the other systems on the platform. And the antennas do come with the system hardware when you buy a navigation system. One of the other areas I talked a little about in the intro is weather prediction. We have been flying radio occultation systems since 2016, and this shows the hardware for GRASS-2 that we are building right now. We just delivered 3 units to MedOps, and so this will be the next step in radio occultation to determine temperature and also humidity. And last, I want to talk about the antennas. We've been doing antennas for over 20 years. We've done wide coverage antennas, CC or TT&C and GNSS type of receivers and beacons. Reflector antennas, I mentioned that on James Webb. We did a composite reflector antenna for that program. Then we do an arrays of different types, and then we have the design and facilities to test and look at the different patterns to make sure that meets the mission requirements. Jumping into spacecraft systems, I'll talk a little bit more on the next slide on the spacecraft structures, but we do satellite mechanisms, and we do mechanisms for solar arrays. We do gimbals, any type of mechanism you could think of BeyondGravity has designed and built. We also do ground support equipment, and that is shipping containers for satellites to get your satellite from where it's being fabricated all the way out to the launch pad. And we do the trolleys also. So in your manufacturing area, you could build up this satellite on a trolley. Thermal systems, talk a little bit more about that, and ending up doing slip rings. On the satellite structures, we have this facility in Zurich, Switzerland, and also in Titusville, Florida. And here we build the actual panels for the satellite platforms. In the upper right shows one of the panels. We include inserts, which are the circles, also wiring harnesses, and thermal management within the satellite panel. This facility in Florida actually runs only on 8 people. It's all automated at this point in time. And the final information on the satellite area is vacuum and non-vacuum insulation. Here's the temperature ranges. We've been doing it for over 30 years in this area. And what you can do is if you need MLI to put on your spacecraft, we can actually take a drawing, and it's an automated system to actually cut the insulation and to get it delivered to you. Talked a little bit about the mechanisms. We do pointing systems like gimbals, but we do also for propulsion systems. And then ground support, here's a trolley that I talked about a little bit earlier. Wanted to put in a slide for our rover lab. This is in Zurich, Switzerland. We do a lot of work with NASA, JPL, and this just shows some of the work. We do have a warehouse that contains different sands that is replicable of Mars conditions, and so we can test out different wheel configurations for the missions that's needed. Next, I want to just touch on the launcher systems. We've been doing launcher systems for a long time. In fact, if you remember RUAG Space, RUAG Space was our name before we changed it to BeyondGravity this year in May. And so some people in the audience might know RUAG International or RUAG Space. As I said, we changed the name to BeyondGravity this year in May. But in this area, we do the fairings and the structures for launch vehicles. And then the subsystems, we do the payload adapters and separation systems. One area that most people don't know we do is guidance systems for sounding rockets. We've been doing that for over 20 years. And here's a photograph of one of the fairings out of our Decatur, Alabama area. If you look, you can see people standing here, and that gives you the visual of how large these fairings are. In the subsystem area, we do the separation system, payload adapters, which I wanted to show you, the dispensers as they're building this up. The dispensers go on top of the launch vehicle, and presently we can dispense 68 satellites at a time. And then structures and navigation controls, as I've talked about before. And the last one is additive manufacturing. We are really seeing a benefit to look at this technology area. We've already proven out that we get a 30% increase in performance on different hardware, and then definitely shorting the throughput time by about 50% of the time. And so how do we get there? So We've been doing space, human space on the International Space Station, and we've been doing that for a while now. Next, we'll be going to cislunar, and it takes about a week to get to cislunar and developing the lunar gateway that NASA, ESA, and JAXA is doing. And then the next one is getting to Mars. And that's a big trip, a lot of planning to do there. But what's the approaches and how do we do it? And how do we keep humans safe as we continue to go deeper into space? So that ends my presentation. I hope that this was educational for you. Would love to work with you, and please, let's connect. And again, here's my contact information, and thank you, and have a good summit.